And then we have a couple of constraints over here. Maybe I'll just call this 1, 2, 3, 4, all right? Okay, so 1, 2, 3, 4. So constraint number 1 is our budget. And so we have the cost here, right? Okay, so that's my budget. And then number 2 is that I need to have at least 10 TV ads. So that means the daytime TV ads and the evening time TV ads have to be at least 10. Number 3, I don't want to spend, I need to reach 50,000 customers, and there's the data for thousands of customers reached over here. Okay, so I have my number of customers reached over here. And then finally, number 4 is I don't want to spend more than $18,000 on TV ads. And then there's the cost of daytime and evening time TV ads. And then something that maybe you didn't think about, but I do see people see it, is that we also need to have a constraint on the number of ads you can buy. Okay? So daytime TV, you can only buy 5. Evening time TV, you can only buy 10, and so on. And of course, you cannot buy negative number of ads, so all variables have to be greater than or equal to 0. Okay, any question on that problem? Media selection? Pretty straightforward stuff. Yes? For which one? Daytime TV, less than 15, correct, yeah. Okay, so let's look at the second problem over here. Okay, that second one is another marketing example, and we have this marketing research problem. So it says MSI here specializes in evaluating consumer reactions to deep fried services and advertising campaigns. A client has hired MSI to evaluate consumer reaction to a new household product that they launch. MSI is going to conduct some door-to-door interviews from households with and without children. MSI will also conduct daytime and evening time interviews. And interviewing costs are shown below. Okay, so an interview during the day in household with children costs $20, evenings $25, no children 18, evening 20. And you're asked to formulate an LP model to minimize total interviewing costs. The company has a whole bunch of requirements. They want them to do at least 1,000 interviews. They want to interview at least 100 households with children, interviews at least 100 households without children. Total number of interviews during the evening at least as great as interviews during the day. Of all the interviews you do with children, 40% of them have to be done at night. Of all the interviews you do without children, 60% of them you have to done at night, okay? So let's look at this problem here then. Okay, so our second example is marketing research. Okay, so our decision variables will be those 4 interviews to do. Okay, so our decision variables will be the 4 different types of interviews we can do. So DC is then number of daytime interviews per child. And then EC is then number evening with child. And then DNC, number day, no child. And then E and C, number evening, no child. So D is for day, E is for evening, C is with children, and NC is without children. Okay, we want to minimize the total cost here. And the cost is 20 to 25, 18, and 20. And once again, I'm going to let you formulate the model yourself. So there are the requirements there. Okay, how many people finish? Okay, maybe another minute or so. Okay, let's have a look here. So maybe I'll just label this as 1, 2, 3, 4, 5, 6, okay? So basically there are 6 constraints in this problem here. Okay, so constraint number 1, have to do 1,000 interviews. So EC, EC, ENC, ENC equals 1,000. Okay, next, number 2. Interview 400 household with children, interview 400 household without children. So 400 household with children, so daytime children, evening time children, 400. 400 without children, so daytime no children, evening time no children, at least 400. And then number 4, total number of evening during the evening at least as great as during the day. So evening, right? So evening children, evening no children, more than day children, and day no children. Number 5, at least 40% of interviews with children have to be done in the evening. Okay, so that's evening with children. Out of all the interviews with children, so that includes both day and evening. So evening as a percent or whatever of the total with children has to be 0.4, right? And maybe write it like this is probably a little bit better. Okay, evening with children, at least 40% total children. And then finally, 60% of the interviews done with no children also have to be done at night. So same drill. Of all the evening no children, out of all the no children, have been done at night. Again, we write it as even in no children, at least 60% of the total no children. And as usual, all variables greater than or equal to 0, you cannot do negative interviews. Okay, any question on that one there? Okay, so pretty straightforward there. Yes?
It would be okay to write it in either form, right? The fraction or the.
Yeah, I think, but this is gonna, Lingo will say this is a non-linear program.
Okay.
So we try to linearize it. Okay, and then next we have a finance problem here. Okay, so finance problem with this portfolio selection, Well Mutual Fund. So Well Mutual Fund, they have 100,000 in cash, deciding what investments to make. The analysts identify 5 opportunities: rate of return, 2 oil companies, 2 steel companies, government bonds. Company has some guidelines on investments, and they are neither industry, oil or steel should receive more than half the money, or $15,000. Government bonds should be at least 25% of the steel industry investment. The investment in Pacific Oil has the highest rate of return, but also continuous high risk, cannot be more than 60% of total oil industry investment. So what is your portfolio recommendation? Basically, the investments and amount that should be made for the $100,000. So very similar to the Bruce Lee, example in the first week of class, where he gets to decide how much money, or what's the percent to put in bond fund, money market fund, and stock fund. Right? Okay, so let's formulate this problem here. Okay, so we have a finance example here with portfolio selection. And again, we have the 5 investments, right? So that's our decision variable again, right? So our 5 investment is AP dollar invested in Atlantic, Pacific Oil, right? And then we have HM dollar invested in Hubbard and Midwest. And then we have G dollar in government bonds. Okay, so our five investment here. I'm just gonna say that depending on your problem, maybe you might have to define your decision variable slightly different. Okay, so maybe in another problem, you might have to define A as not dollar in Atlantic Oil, but percent of money put in Atlantic. And that was what we did with the Bruce Lee problem in lecture 1. Because we didn't know how much money Bruce Lee have, right? So we will have to define it as a percent put in each, right? Because we don't know how much money Bruce Lee have. So that way we have to do it like that. And then you could, maybe in a different problem, A could be number of units or shares of Atlantic to buy. So here we don't have any share prices whatsoever, so we can't not really do it like this, but maybe in a different problem you have, and so maybe you want to do it like that. Okay, so once again, we in this problem we want to maximize the return. Okay, so once again, I'll let you complete the problem here. Have I posted assignment 2 yet? Okay, alright.
What is this on?
Okay. Alright, how many of you finished? More hands, okay. Okay, 1 minute. gonna finalize the midterms today and then send it to the print shop in the afternoon. Okay, so let's have a look here. So there's the projected return. And so if you put $1 into Atlantic Oil, how much money do you get back? If you put $1 into Atlantic Oil, how much money do you get back? I thought you guys are done.
7.3 cents.
Yeah, 7.3 cents back, right? So every dollar you put in Atlantic Oil, you get 73 cents back. And then same thing for Pacific Oil, every dollar you put in Pacific Oil, you get 10.2 cents back. And then, once again, I will just, there's the 3 constraints over there, right? Constraint number 1, neither industry oil spills should receive more than $50,000. So therefore, my 2 steel companies cannot be more than $50,000. My 2 oil companies cannot be more than $50,000. Government should be at least 25% of steel. Government at least 25% steel. Number 3, Pacific cannot be more than 60% of total oil. Pacific cannot be more than 60% total oil, so oil is A and P. And then something maybe you forgot or maybe you didn't forget, only have 100K. And so everything together, oil, steel, government bond cannot be more than 100. And of course, cannot invest negative amount, so all variables need to be greater than 0. Okay, any question on that problem? Yes?
Can't you like have negative variables in this question? Because couldn't you short like the government bonds to have negative amounts?
Well, it didn't seem to allow you to do it
Okay.
in the problem. So suppose well, a few things. When you look at this here, you can, I guess, collect terms, right? Move the P to one side and so on. And then you get 0.4P, subtract 0.6A less than 0, right? So you could have did a little simplification like that, right? Don't do it. Okay? the book does this in their solution, and I hate it. Because students will come to me and say, what is this? And I have to say, well, they started with this and they simplified. And they go, okay, I get it. This reads like English. Pacific, less than 60% total oil. This is impossible to understand where this comes from, right? So you try to leave your constraint in a way that's easy for somebody else to understand, right?
Simplify that into passport.
Another question is, suppose somebody on the midterm, they do this. Okay, they don't have less than equal to, they put it equal to. So, you're grading, do you mark them right, do you mark them wrong? Do you mark them right, do you mark them wrong?
Wouldn't it be wrong?
Would that be wrong? Okay. Anybody else have an opinion? Yes?
Partially correct.
Correct? Okay, you have an opinion?
I think it's right because you'll use the 100,000 anyway.
Yeah, in this problem, you're right, either way, because everything makes money, and there's nothing stopping you from using it all up, right? There's nothing stopping you from using it all up. So therefore, in this problem, either one is fine, right? So in this problem, both are correct. Because you will use all your money, right? You will use all your money. There's no reason to. Unlike our lecture 1, which is a more sophisticated version. Bruce would like to hold some of the funds as cash in case of emergency. And the amount of cash should be at least 2% of money invested in stock. Therefore, you no longer can invest all your money, right? You no longer can, so unless there's that. And then there might be some other things that you might be, not thinking about as well. There might be some other things stopping you from investing. And so, we try to leave the model to be as flexible as possible, right? So however, the less than equal to version is better. Because it provides more flexibility and avoids getting you in a situation where you have an infeasible problem. Okay. Because if it is possible to use up all the money, when you leave the constraint in this manner and you solve with Lingo, it will end up using all the money anyways. Okay? So you don't have to force yourself to use all the money. So there could be some other constraint in the problem. Maybe you cannot exceed a certain risk or whatever it is that would prevent you from using all your money. And if you force yourself to use all your money, then you're gonna have an infeasible problem where it says we cannot use all our money and still be able to satisfy our risk. So in terms of modeling and putting down constraints, whenever it's possible, we try to leave as much flexibility in the formulation and let Lingo work it out, right? Okay, where's the sign-in sheet, please? Sign-in sheet? I'll just take it to the front, you can do it. Okay, if you haven't signed it, you have a question? Oh. Okay, you have signed in, sign in. You missed last week's class, you can have a look. Okay, so 10 minutes.